This is video 9.2.1, and the goal here is to understand parabolas. So let's take a look at first the definition of a parabola. A parabola is similar to an ellipse in that it's going to have two focus points, but the set of points that describe a parabola are the points with a difference of whose distances from two fixed points are constant. So instead of we're adding the two distances, so we're picking a point, the distance here and the distance here, the difference between them is constant. Okay, so they show that here as well. The difference here, d2 minus d1, will always equal the same amount. Okay, the difference between the distances is constant. So this is going to describe some real-life situations that you'll see in the next video in the next half of the section. Let's take a look at what the equation looks like. So here's the good news. It's pretty similar to your ellipse equation, but there's some big differences. The first difference is that it's a minus instead of a plus. That means that notice that the y appears first here and the x appears first here. Okay? This rule corresponds to a graph that is pointing in the left and right directions. Okay? So these are opening left and right. The y one, when the y appears first, is going to open up and down. Okay? So that's one difference between why it's important to notice the subtraction and notice who's first. It'll help you decide which direction to open this hyperbola. The second thing that's different is how to get the foci. The foci are now the sum of a squared plus b squared. Remember with ellipses it was the difference between the two. Well, now it's the sum of the two. So we have some similarities and differences, and when one thing changes, the other changes as well. So that's some interesting similarities between ellipses and hyperbolas. Let's take a look at one example, and then we'll jump right into some more complicated ones. So here's what we'll have to do in order to graph. Okay, we first notice that the x appears first, and we see 49 can be written as 7 squared. Okay, 15 is not a perfect square, so we're going to think of it as the square root of 15 squared. Or it's going to be a little bit, b value is going to be a little bit smaller than 4. So what this means is we also have a centered around the origin. So what we have here is it's going to go 7 units to the left and to the right of the center. So here we are 7 units to the right, and we're going to go 7 units to the left. Okay? Those are going to be my vertices. That's actually where the parabola will appear. So the parabola is going to look something like this. Okay? But I'm going to hold off on drawing that because I'm going to be able to figure out how wide this parabola is by looking at the other value, the square root of 15. So that's a little bit less than 4. So I'm going to go up 4, and I'm going to make a little mark here. And I'm going to go down almost 4 and make a little mark. What I'm going to do here is draw a box. I'm going to draw a box that is going to have the vertices on the midpoint and will be square root of 15 from the center. Okay, so this is square root of 15. That's the distance here. Okay, this box helps me draw my asymptotes. Hopefully you noticed in the previous picture that there was some definite boundaries and that this left one opened a little bit wider and this one is much more narrow. Okay, the way we're going to figure out how wide it opens is through an asymptote that we see right here. It's going to be a line that we can draw from one vertice to the next. That is going to be my asymptotes, and we have another set of asymptotes here. Okay? These are my two sets of asymptotes that will describe how my parabola opens. Now I'm ready to draw my parabola. I mean my hyperbola, excuse me. It's very similar to a parabola, but there's two pieces, and they do have a slightly different opening. Okay, so this hyperbola is going to hug the asymptote as we go to infinity. In fact, I probably should have drawn a little bit more curved in here. I'm going to get to the asymptote a lot sooner. So there's a hyperbola. Okay, so that's the basics. It's this box, this red box that you have to learn how to draw. And once you draw that, you're home free. Now, remember, we also want to find the foci because they're important for the application. So we're going to add the two values, 49 plus 15, and that equals c squared. So in this case, 64 is c squared, That means C is 8. So once again, it's 8. That means a distance of 8, and it's 8 from the center. So we're going to go over 8 and see my first foci is here, and my other foci is 8 from the center in the other direction. Okay, so this distance here is 8, or the length of C. Okay, so that's the basics. Now all we're going to do is shift everything in order to write it for more complicated ones. So let's take a look at your notes that you're going to add. So in your note packet, you're going to add the following to your notes, and we'll add the second one in class together. So just get this one in. We're actually going to do the Y one. So make sure you're in the Y one, the one that opens upward. Okay, are you on the right one? Should be the one at the bottom of your notes for hyperbolas. So the equation for a y squared, we just saw an x squared one. This is a y one because the y would appear first over a squared minus x minus h squared over b squared equals 1. That's the rule for a hyperbola that is oriented the way you see the one on the right. The center is at h comma k, just like we're used to. So notice the h is always with the x value and the k is always with the y value, of course. The foci will be the same whether we're dealing with a hyperbola that opens upward or to the left and right. We're always going to add the two values that are underneath in my denominator. And in this case, the vertices will be above the center and below the center. So the h value will stay the same, but we're going to go a above and we're going to go a below. So k minus a. Okay, so that's what we see here. We're going up and down a. The one thing these notes don't have is the box that I talked about in the last picture, in the last problem. So this box is actually going to be a box that goes through my vertice and down. And the question is, how do you know how big it is? Well, first of all, one part that's easy to figure out how big it's going to be is the height of it. Okay, this will definitely be a below and a above. So this is definitely going to be 2a. The width will be 2b. Okay, so here's how we find the box. We're going to walk b over and walk b to the right. Okay, that's how we're going to figure out how big this box is. And that helps me draw in my asymptotes. Okay, so that's how we find the asymptotes. So it's all a very visual process in order to find the values. Okay, that's your notes for the hyperbola. Let's take a look at a problem. Graph the equation of the hyperbola, use the asymptotes to draw the graph. So let's start with finding the center. Okay, so it looks like we're going to go x3 because it was x minus 3, and we're going to go up 1, or I'm sorry, down 1 because it's at y plus 1. I'm going to figure out how far my vertices are away by that 3 squared. So that means my vertices are going to be 3 above and 3 below. The reason I know it's above and below is because the y value occurred first. So I'm going to go up and down to find my vertices. Now I want to start thinking about drawing that box. Okay? So my box I know is going to be this tall. It's going to go from here to here. But how wide it is depends on the second value, 7. So the square root of 7 is approximately 2.6. So that means that I'm going to go left and right 2.6 to figure out how wide the box is. So from the center, I'm going left 2.6, and I'm going right 2.6. And in fact, from every point at the top here, I'm going to go right 2.6 and left 2.6. So I can start to see my box forming. This is going to be my box that will help me find the asymptotes. Okay, so 2.6 and 3. Those are the A and B values. Okay? Now I can draw in my asymptotes, and the verticalness is it's going to be a vertical hyperbola, so that means my asymptotes will help me figure out where the boundaries are. So let's take a look at this one. It's going to have an asymptote here, and it's going to have an asymptote here. Now the trick is, do we draw the graph here, or do we draw the graph here? And we know it's here because of the y occurring first. So I'm going to erase this other one and draw above and below. Remember my vertices that I graphed earlier. So there is your hyperbola. Now to find the foci, I'm going to add 9 plus 16, 9 plus 7 to get 16. That's the value for c squared. So c is 4. So remember, that's a distance. It doesn't mean the value of 4. It means a distance of 4. So I'm going to go 4 above and below my center. So 1, 2, 3, 4. There's my foci. And 4 below my center. 1, 2, 3, 4. There's my other foci. Okay? They should always be inside of those curves because they're kind of pulling the curve towards them as the curves shoot off to infinity. So that's the first example. You're also going to have to be able to write rules. Let's take a look at that one. Here's the standard form of, we want to write the standard form of this hyperbola given the graph. So a couple of things. This graph is a little hard to read, but this is a foci and it's at -3 and another foci at 3. Okay? So that tells me that this must be my vertice because it's along the same axis, we can think of it as. Okay? So I see it opening left and right, so I know it must be an x. It must have x first. And I also notice that it's centered at the origin. Okay? It's centered at the origin. So it's going to be x squared over something minus y squared over something. And I know the x value is going to be over 1 because of this distance of 1 right here. Okay? But the other thing that I know is c. I know c is 3. So that means c squared is 9. And I know c squared is always a squared plus b squared. A in our case is 1 because we know that distance. But we do not, what we don't know is b squared. We do not know b squared. So what we're going to do now is solve for b squared. Let's see, minusing 1 from both sides, we get 8 equals b squared. Well, since my rule has b squared in it, I can stop right there and change this out with 8. So this value here is going to be 8. And if I wanted to draw in the boxes, I could, but the important part was to write the rule, and we've written the rule. Okay, so you have to use your relationships backwards when writing the rule. Now it's your turn to try the checkpoints. So give these to your best shot and bring in your questions into class.